All right, so thank you very much for coming back and welcome to this keynote session from Rachel McDonnell. So let me briefly introduce Rachel. Rachel is an associate professor of creative technology at Trinity College Dublin in Ireland. Her research focuses on the animation of virtual characters. In particular, she's the best person in using perceptions to both deepen our understanding of how virtual characters are perceived and also directly provide new algorithms and guidelines for the industry to know where they should focus on. She has already published over 100 papers in good conference and journals in top-tier publications such as SIGGRAPH, Geographics, TVCG, and so on. And she also served quite a lot in the community. She served as the associate editor on the journals such as ACM Transition on Applied Perceptions and the Computer Graphic Forum. And she's also a regular member of a lot of international program committee, like a lot of SIGGRAPH, a lot of Geographics. So it's my honor to have Rachel here to share with us her insights. So without further ado, I will pass the mic to Rachel, and thank you very much.
Thanks so much, and thanks for having me. So today I'm going to talk about oversharing in VR. What does our motion reveal about us? There's a kind of a cryptic enough topic, but we'll get to that in a minute. So as I said, yeah, I'm an associate professor at Trinity College Dublin. So our university is a pretty old university, like here. And yeah, the main topics that we work on there are computer graphics, virtual reality, character animation, virtual humans, and perception. So I'm part of the graphics, vision, and visualization group there, which is with Professor Carl O'Sullivan, which many of you will know. So our group has combined graphics and vision researchers for quite a while, even before there was an obvious connection between the two. So it's a really active research group. My own research group, I've put a picture up here to embarrass them because there's a few of them here, there's more of them here. So I'm working with a great bunch of students. And we were talking a bit last night about diversity in PhDs. So one thing I like to do is like obviously have diversity in gender, but also in the kind of background. So we've got computer engineering, science, of course, and mathematics, but also some of the students have more diverse kind of backgrounds like philosophy. One of them did his major in philosophy, music composition down the back, cognitive science, creative arts, and even architecture. So these are, yeah, quite a diverse bunch of backgrounds. So I believe it brings a nice kind of different flavors to what we're researching and different ideas coming in from different angles. So that's my group. So today I'm going to talk a bit about the metaverse, which is a word I think people are kind of sick of hearing, but and whether or not it'll happen or not. But for me, you know, when I started computer animation, we're talking about SCA. So my first SCA, I think, was about 2006. So it must have been the fourth year of SCA. But back then, yeah, like VR headsets were very cumbersome, lots of LED screens. Motion capture was very complicated and, you know, required a lot of computation. So for me back then, as a PhD student, to think that we could potentially motion capture ourselves live, co-inhabit spaces with other people motion captured live. I mean, obviously that was kind of science fiction at the time. So for me, I'm still very excited about this idea. I think there's so many interesting questions around, you know, what it is to even be human in a space like this, if you're representing yourself as a virtual character. What do those interactions mean? So if you have some meaningful conversations with virtual, we did some of our lab meetings in VR over the lockdown, and you know, there's some good interactions, things like that. But like, how does that even form in your brain as a memory? Or you know, these are all questions that are going to be really interesting to look at in the future, and especially with the computer graphics rendering and real-time ray tracing becoming possible. You know, the worlds are becoming extremely realistic, and again, I think we're moving so quickly with the with the graphics that we need to take a step to the side as well and kind of think about, well, what does that mean for our perception and how we interact as humans, and what does it mean to even be human in these worlds. I suppose the first thing about representing yourself in a virtual world is, how do I represent myself? Do I, choose a nice kind of cartoony representation, or do I go for something highly realistic? And these are kind of questions that I've been looking at throughout my research about the importance of representation of a virtual character and what that means to your perception. There's another something that happened during the lockdown. I don't know if did everyone see this poor guy, this lawyer that got stuck in a cat in a Zoom call. So he didn't know how to turn off the filter, and just said, this is really me, I'm not a cat. But I just thought that was absolutely brilliant, because it was his motion behind the cat, but it was obviously a very scared looking cat. And again, I imagine in the future we're going to have all sorts of weird interactions where people, maybe even photorealistically, can represent themselves as animals or other creatures. So yeah, I think that's kind of exciting. One just side point before I get on to motion and the perception of motion. One thing that we've looked at a little bit is about facial features, and I think it's kind of relevant in some ways, because it's about choosing your avatar, and an avatar that's a good representation of you. But what people might not know is that there's a lot of studies in psychology that have looked at the link between facial features and personality traits. So there's been loads of research looking at real faces and looking at the facial width to height ratio and how that's related to more dominant individuals, more aggressive, less honest, less appealing. And then other properties such as the eyes have perceptual consequences in terms of personality traits as well, related to dominance and honesty. So basically, when you see a face, your brain has already made some assumptions about what that personality of that person is. And we've done some studies with my student Ulva Firstel on looking at this idea of facial features, virtual characters, and abstract characters, and other researchers have looked at robots and other virtual characters as well. So in general, a lot of the same, interestingly, a lot of the same perceptual traits are seen in realistic virtual humans. Is the same kind of thing as real. But we found in the more abstract looking characters and robots that there were some differences in how the face was perceived. So, for example, narrower faces were perceived as more dominant in those cases. So what is the point of this to do with metaverse? Well, I guess, depending on the avatar creator, even if you're trying to look like yourself, there's, small differences in width to height could affect how you're represented and how you are perceived, even from a visual point of view. So I have a couple of images here of avatars that I created of myself over the lockdown. So like that in a few different avatar creator systems. So ranging from really kind of cartoony to quite realistic. Again, they're quite varied in visual style. So for me, I find it very interesting to think about, what kind of avatar should represent me in different scenarios. And would you be taken seriously in a meeting with as a cartoon avatar, or just generally, how the facial features of those avatars are perceived, and then how am I perceived behind that avatar. So we did run one study on cartoon avatars over the lockdown, where we embodied our participants in a Zoom call in cartoon avatars, because we were interested to see if negative valence conversations were possible when you're as a really cartoony, friendly looking avatar. And we actually found that there was no issue with the avatar in that case. People were able to discuss kind of negative and serious topics, even when they were embodied in a cartoony avatar. So yeah, I mean, I think there's loads of more research to be done in this area to see what avatars are kind of appropriate for what situations. So, okay, so that's kind of appearance. Yeah, that was the experiment that we ran with Zoom. So this word embodiment, just in case there's anybody that doesn't really know what that is, embodiment basically just means the possibility in VR to visually substitute your real body with a virtual body. It's supposed to be life-size, and it's from the person's own first-person perspective. The illusion of embodiment works really well because of the plasticity of the brain and how we can take on another body as our own. So it's a really, really strong illusion, and it can be enhanced. There's a number of different ways it can be enhanced. The main one being if you look at a virtual mirror and you've got visuomotor synchrony between your avatar and your movements, and then you get this high sense of feeling of embodiment. And there are other ways of doing that as well, but that's certainly one of them. So for the user to be fully embodied in the virtual avatar, generally you're going to want pretty highly realistic tracking of the body. So, you know, real-time tracking, you might need some mobility in space and haptics as well. But the one that I'm interested in, and I guess it's kind of more relevant to this community, is the real-time tracking. So in VR, the level of realism of movement is obviously going to depend on the number of tracking points that you have, right? So, you know, it can range from full body motion capture suit to just a couple of trackers with the VR headset. So yeah, so I guess the rest of my talk is kind of interested in this whole idea of, you know, how many points do you need? What kind of, if there's artifacts in the motion, how does that affect you? And just generally, yeah, just generally, how is motion perceived? You know, that's driving behind all these different appearances. So I'm going to go back for a visual illusion. I think we said yesterday that people like these. So, okay, I'm just going to show you this point. This is from experiments in the 1970s, so excuse me. So you saw that point was oscillating, right? So now when we add in some extra points, we can kind of see a difference in that point, right? So the point no longer looks like it's oscillating. Did you ever see that? So now it looks as if it's moving in a group over and back, and then moving vertically up and down. So this is basically just a demonstration that our brain is very good at grouping motion. So look at this point here now. Does anyone have an idea what that might have been, that point there? Did anyone even see it?
That's a rabbit.
A rabbit? Maybe? Good guess. Okay. A wheel? Yeah, it looks like a wheel, doesn't it? It kind of has this kind of oscillating movement. Well, I'll group it with some more points and we'll see if it's a bit clearer what it is. So that's the point. So any ideas now? It's very clearly a leg, right? Walking across the screen. So we're grouping together, we're getting better knowledge of what's going on by the groups. Here's another example. Again, it just looks like kind of an oscillating point. But when we add in some more points, let's see what that's coming from. So again, this just looks like a bunch of points. But then when they start coming to life, you can very, very quickly and very instantly see that that's a human body walking, right? So this is the ability of the brain to understand the connections between points very well, and oscillating points and pendulums. So you can see here that it works not only for walking, you can really understand very easily what the human is doing in all of these, can't you? There was one painting there, this guy is doing some push-ups. So there's real clarity in what's happening there, and that's because of the human brain's ability to interpret biological motion or human motion. So these were basically experiments done back in the 1970s by Gunnar Johansson in Sweden. And back then there was no motion capture suits. He was putting light bulbs on the major joints of a human. and blacking out and doing all sorts of kind of things with the video camera to try to get these effects. And his main interest in that was to see if we were to take away all form and just have the movement of a human, what can we actually interpret from that? And there's been hundreds of studies looking at what these are called point light walkers. And there's hundreds of studies investigating biological motion, what is the foundation of it since then. So there's lots of interesting properties of it. But I guess for the purposes of this talk, the main thing is that humans are really, really good at identifying when a sparse set of motions has a pattern, whether it's biological or not. And this ability to distinguish between biological motion and all other motions happens really, really at a really young age. You can see that just general points there, then the point light walkers. Okay, so moving on from Johansson's early work, Nico Troye, his lab, the biomotion lab, and others as well, started to look a bit further. And so, you know, it was clear that we could determine especially gait, but also what motion a person was doing. So whether they were, you know, walking, running, whatever they were doing, you could identify it. So then people started looking a bit more closely at, you know, the individual and what properties does that motion actually hold. So gender was one that was a very common one, motion from gender from motion. And there's some examples here in Troje's lab, they did some early classification, machine learning work on human motion quite a long time ago to try to classify emotion as either male or female or whatever gender it was. So other researchers then have looked at identity as well. So like you actually have the ability to recognize your friend's motion from just motion alone, which is really interesting. So it's just showing, I guess, how rich just even this small set of points is in information and how much we can actually get from it. Emotional state can also be taken from it. So if you're walking in a happy mood or a sad mood or whatever, that can be picked up from the motion alone. The state of your health as well. And I guess some other work like Michael Neff has been looking at gestures as well, and that gestures can also reveal things like personality traits. So, and these can be seen from even a bunch of points. So I suppose all this information, how does that relate back? Well, we'll talk a little bit more about that in a minute, but I guess at this point, just to understand that like any amount of tracking that you're doing of your body in virtual reality, the information that your motion alone holds is quite a lot. So this kind of work back in my early PhD, what I recognized as really interesting from this was the ability of, well, first of all, we could use motion capture to do the point light experiments very easily, but also we had the ability to test not only motion alone, but motion and form and different combinations of shape and motion. So that's something that's very unique, I guess, to computer graphics, that we can apply motion of one character onto the body of another character. And you know, back then, I think myself and Carlos Silva were more interested in this more from just a perception and an interest point of view, and also for computer games and visual effects to see what the effect of if you had captured the actor and you applied it to a different model, what effect would that have on perception. But I guess I'm rethinking some of this work now in the context of the metaverse or coexisting in VR, and thinking again about how our emotions when we're co-inhabiting or we're virtual tracking humans, how they will be perceived. So yeah, we started with the classic paradigm of the gender from motion to try and replicate some of the early studies in the 70s, but with different body shape. So we got some male and female walkers and applied the motion to male and female characters. and we got a range of different effects. So we tried a kind of a gender neutral body shape as well as the point light walkers, and we did the same for female. Again, we only had 3 female, 3 males. I suppose if we did study now, we'd look for more gender diversity. Yeah, so we tried out 3 males and 3 females, and we applied the motion then to the different body shapes. Yeah, so we wanted to see then if participants were able to determine, so we know from point light walkers alone, people can determine things like gender, but what if you mix the gender of the virtual character and the notion behind it? What does that do to our perception? So interestingly, we found that gender is very much recognized for motion as expected, but appearance and motion, appearance and motion. So if the motion isn't, so we created a neutral motion from a synthesized animation. And if you've got a neutral animation, then the appearance then overtakes. So the gender of the appearance takes on the overall appearance. But in general, we never had any situation where we saw the motion of, like for example, the motion of a female applied to a male. It wasn't considered male. So I guess what we're saying here is that the motion is really strong cue, and we found the same when we did it for we continued the work for gestures. Again, we found, I had videos here, but I don't know where they're gone. We found that the motion was the strongest cue, even when we applied male motion to a female actor. The male motion of the underlying actor could be determined very easily. So I guess how that relates back to the metaverse is that if you're if you identify as female and you're you want to represent yourself in a male character, that the motion of the actor is the one that's going to be seen. So other researchers have looked at gender from facial characteristics, and they found again that it could be recognized from facial motion alone. But I think this is more of a social kind of effect of those, for example, there's more blinking and nodding apparently in the female characters. So I don't know, let's see. So anyway, so that was gender. So that we kind of tried to replicate the classic experiments, but then we started to think a bit more about maybe things like emotion. So we went back to the Ekman's 6 basic emotions, which is a basic kind of a model of emotion, but we wanted to just try something kind of straightforward. So we these videos don't seem to be. Oh, yeah, these ones work anyway. Okay, we'll look at those in a sec. So we looked at the basic emotions, and we found that yes, from point light displays alone, this was an actor acting out very exaggerated emotions. We thought this was a good starting point. And yes, the emotion of the actor could easily be identified by the motion points alone, but also by a virtual replica of the real. There was absolutely no difference in how the emotion was perceived. We then tried a bunch of different body shapes. So we thought we would try, a low res human to see if the low resolution of the polygons would affect the perception. We tried like a kind of a wooden character with androgynous appearance. We tried a cartoon. And then we decided to try a zombie character with decomposing flesh to see if that would affect. We were really clutching at straws at that point. We call this the happy zombies paper. So we applied the motion to all the different body types, and we ran a kind of a detailed emotion experiment where we looked a bit more detailed. So again, all of the experiments I'm presenting here are where we would bring in a sample of participants. Back then it was always into the lab, often it's online now, and you would conduct an experiment. In this case, the experiment involved identifying what more complex emotions. So not just saying, is it happy, sad, whatever. We were kind of interested to see if like words like rage and, you know, anger would, you know, be different on the different body shapes. So if there was like subtle differences between how you perceived a zombie looking happy versus another human, how would that actually come out? So interestingly, we found again that motion dominates our perception of the portrayed emotion. So basically we could, that's why we tried the zombie, because basically the motion is so rich in information. And again, this goes back to Johansson's experiments. The motion behind the character is so rich in information that it really didn't matter what appearance we applied to it. We were getting the same results, even like the subtleties of emotion, the difference between rage and anger, for example, was perceived exactly the same on a zombie character versus a real. So I suppose that was a big surprise to us then, that we found no negative reaction to the zombie character, and that everything was being perceived in the same way. But again, throughout all the studies that I did back then, there was just this all underlying, we were always trying to get an effect of appearance, but the motion, the properties of the motion were so strong. So it really didn't matter what appearance you were applying, the content of that motion, and it was good quality motion capture, had everything that you needed to make your decisions about it. And I guess, again, I'll come back to the idea of the metaverse again, but for me, this kind of relates to the fact that if you, regardless of what avatar you're choosing, you know, the motion that you have behind it, the person that you are, is going to kind of shine through, I guess. And what emotion you have, what personality you have, anything like that is going to be kind of dominant. So another aspect of that's often studied in psychology is personality, and psychologists have been looking at ways of categorizing or finding taxonomy for personality traits for years. The Big Five seems to come out quite often, and it's used quite a lot in computer animation as well. I guess it's because it's a straightforward enough set of 5 personality traits. So you have openness to experience, emotional stability, so the opposite of that would be neuroticism, extroversion, agreeableness, and conscientiousness. So this idea emerged in the 40s, still widely used. I mean, this, as with the emotion, 6 basic emotions, there's always a lot of debate around whether this is a good idea or not. But for the purpose of studying something in computer graphics, these models, these models can be very useful for us to try and determine how things are being perceived on virtual characters. So we ran an experiment. So we looked at all the psychology literature at the time to find what properties in just the head and eyes. So if you just had your head motion in your eye gaze and your blinks, you know, can you represent a virtual character? So based on all the literature that we read at the time, we came up with this. Now, we didn't do all the Big Five, but we did 3 of the Big Five, the polar opposites of them. Yeah, so we found, and we got an actor then to act out these different personalities just in the head and eyes, which seems a bit weird, but we were interested to see at the time if you had an agent, for example, a conversational agent, if you could just change the way the agent moved, blinked their eyes and nodded their heads, could you give a different personality up and make it a bit more diverse? Anyway, again, we found here that yes, personality was perceived in the experiments that we did through just eye and head movement and nods, implying again that there's a lot of rich information coming from just the head and the eyes, for example. So just that motion alone is kind of giving a lot of information about personality. Again, here we tried like a realistic model and a cartoony one. We felt that the cartoony one would be perceived as more agreeable or, more, I don't know, something different. But again, we found no difference in the appearance, whether you applied it to a realistic character or a cartoony model. So again, implying that the strength of the motion behind the performance was outshining, I guess, whatever you represented it as. Just check the time. Okay, so this research was done in our lab by Professor Carla O'Sullivan with Ludovic Hoyt, who a lot of you know here. So this study, I just thought I'd bring it up here as well because they went on to look at distinctiveness of motion, which is kind of relevant as well. So the early studies showed that motion can be identified like you can identify your friend based on the motion alone. But this study looked at a kind of a homogeneous group in terms of their height and weight, and gender, for example, and applied the motions to the exact same character. So trying to see, what is it about the individuality of the motion that's a show, and I guess the purpose was to then be able to create more distinctive motions or to see, for example, in a crowd, how many different kind of walking animations or running animations do you need. So they found that distinctiveness was easily detected. So they ran an experiment where you had to kind of identify the same walk from a different walk cycle, to see could you determine which individual the walk was coming from. They also looked at if this was across motion. So if you had a very distinctive kind of style in your walk, did you have a very distinctive style in your dance, for example? And they found that this was not the case, so it didn't transfer from one motion to another. So there's lots of kind of interesting follow-up studies that could be done related to that as well, especially with regards again to the idea of metaverse and whether your distinct personality comes through regardless of emotion. I think one of the findings they found was that the more physical the movement, so if you were punching or kicking or something, the less distinctive it got. So it became kind of almost like a physical thing rather than, walking, there's a lot of style involved, and same with gesturing. But yeah, once the motion became kind of more physical, the distinctiveness kind of left a little bit. So again, so another experiment, just very quickly, we did a truth experiment where we asked truth and lies. We got somebody spontaneously to either tell the truth or tell a lie. We applied it to virtual characters, again, to see if there was a negative effect of like uncanny valley effect or something of realism. But again, our results showed that the motion of the performance that was behind was the thing that dominated the perception again. So it really didn't matter what avatar you presented these truths and lies on, they were perceived in the same way regardless. So again, it's just a kind of common theme. And we brought that theme forward into virtual reality. So these are studies by my postdoc at the time, Katja Zubrik, who's in Rio now. So we did lots of experiments in VR, looking at, again, we looked at changing the style of the avatar and the virtual space they were in. Really interested in knowing the effect of realism. So if we start to go to more photorealistic environments, does it increase things like presence and place illusion? So in that case, we found, yes, that a place illusion, and so the feeling that you're in a space is affected by the realism. So the more realistic the depiction, the more in the space you felt, which I guess is kind of obvious in some ways, but kind of important to show it as well. But also your ability to coexist and to feel you're coexisting with another human did depend on whether the character looked realistic or not. But again, personality, we tried this with different personalities of our virtual character, and that was the thing that was the most strong. And now we did this across a number of different studies, but we tried a behavioral measure where, so this person in black here is the participant. We're reconstructing the experiment. So we did a full body Vicon motion capture of the participant while they were in VR, which is actually a really good way of getting really rich data about what the participant is doing. Again, I imagine there'll be lots more experiments doing things like this in the future when we have better systems for virtual tracking. But we tracked the character, and they had an interaction with this character. The character was either kind of friendly or unfriendly. We tried different personalities. And then after the conversation, we got the participant to walk around and pick something up from behind them. So you saw the kind of, this is a behavioral measure of proximity, where you measure how close the character comes. You can see they give the participant walks quite a good bit away from the character, giving them kind of a lot of space. So we were interested to see how close the participant would get to the character. And in these studies, again, the realism of the character had no effect on how close the participant got, so it wasn't affecting their behavior. But what was affecting their behavior was the personality of the active performance. So if the personality was a more negative personality, the participant would have walked further away, whereas or felt more uncomfortable. So again, regardless of the style, this seems to be the personality that was the thing, even creating a behavioral effect in the participant in VR. So yeah, I hope I'm explaining how does all this relate to the metaverse. But yeah, it's all those studies that we looked at. I guess the common theme amongst them is that and dating back from the 70s, this idea of biological motion. If you're gathering motion from a human, it is rich, really, really rich in information. There's lots and lots of information there. And that information seems to shine through regardless of realism or polygons or zombie flesh. It seems to be shining through. But I guess one question that came into my mind then as well was the ability to then detect your personality or your emotion or your physical state, your, you know, any of those things. So if you are spending a lot of time, say in the future in VR, you know, what's stopping anyone from storing this information about you? So about understanding, about like interpreting or classifying your personality from the way you move, classifying what emotional state you're currently in, classifying what gender you are or what age, I presume, as well. So I think it's probably something that we haven't thought about a huge amount in terms of the metaverse, and how this rich information is kind of just there the moment you put a headset on. Because even some of the early work by Kowalski and Cutting, they found that even just and you saw yourself kind of when we saw that just the leg motion, but they found that even just like markers on the ankle and the hips was enough to give information about things like gender. So yeah, I guess, you know, it's kind of an interesting thing to think about, you know, if we're going to be interacting a lot in VR, and you know, there could be the ability to store our emotion and what's going to happen with that. Okay, so that's one point. But then I suppose there's just one or two other questions. I don't know how I'm doing on time. Okay, yeah, I have two more questions to pose about this. One of them is then, so what happens then if the motion quality is lower? So everything that we've been talking about up to now is assuming like really high quality motion capture, captured from like, you know, 50 points on the body Vicon motion capture system. But what happens then, yeah, when the motion quality is lower? Or I know, for example, we did some of the VR kind of virtual spaces. Sometimes animation is procedurally generated. So, for example, I think it was in Horizon. I'm not well, one of them anyway. We our gestures were being procedurally generated. So there was no tracking of the hands. So the hands were just gesturing kind of procedurally, maybe based on what we were saying. Similarly with the facial animation, that's often procedurally generated based on your audio. So again, it's got no real information. I mean, there's some audio to emotion. We saw some papers yesterday, but generally the methods are just producing some sort of animation for your face that may not exactly be what you did. And again, I guess some of the machine learning techniques that are going to fill in the gaps for you know, what gestures we're supposed to be doing, what facial gestures we're doing. You know, I guess, how is that going to affect the overall perception of you in a virtual world when that's happening? So again, I think this is a kind of an open question that requires a lot of follow-up work. But we've done 1 or 2 studies ourselves looking at that question. So this was one study at IEEE VR last year that we looked at, again, the big 5, so the different personality traits. We used the Talking the Pans Facebook data set of gestures. So there's a number of different actors there gesturing naturally and with audio. In this one, we were also interested in speech and whether or not the speech was realistic. But for the purposes of today, the main thing that we were looking at was motion realism and if that affected perceived personality. So what we did there was we used we had a phase classifier that Ova, so this is work with Ova Person as well. She had a phase classifier which classified gesture into the different phases. So we used that classifier to basically kind of chop up the natural motion and generate a robotic version of it. So where we just kind of interpolated to a mean or to a static pose in between. So we're kind of trying to replicate the types of robotic motion that you see when gestures are generated in real-time systems. But again, we kept the gesture phase, so the synchrony with the speech was still there. So we ran a bunch of experiments with lots of different characters and personality styles. And again, these were more natural personalities, they weren't active personalities. And we wanted to see if the procedural animation or the robotic animation affected the perception. And I guess as expected, it did have an effect. So again, like up to now, we've been making the point of how important motion is for perception. So I suppose it's unsurprising that if you dampen the motion or if you change the motion, make it more robotic, it's actually going to change things like the perception of personality. Sorry about this graph, you don't have to know what's going on here. But basically, what we found was that motion was important, particularly realistic motion, for portraying things like extroversion. So once you started applying the procedural or the robotic motion, the characters lost their extroverted trait, or they lessened it at least. The robotic motion was also, oh yeah, funny enough, it was considered less extroverted, but also more conscientious. So the robotic, yeah, they gave this kind of conscientiousness vibe, maybe. They looked very, yeah, I don't know. But similarly with the speech, we found some interesting results, but not really what we're kind of making a point today, but the speech as well changed as expected. I guess we used a kind of a text-to-speech voice, and that affected things like agreeableness and emotional stability. Okay, so yeah, I suppose that's making the point about tracking. So we looked then at tracking failure. So this was Ulva and Michael Neff. She did an internship at Facebook. So we looked at tracking failure. So what she did there was on the right is the motion capture, and on the left is the simulated potential tracking errors. So they were looking at things like, for example, if your hands are only tracked in this space, if the hand went outside, they were doing raycasting to determine if the hand went out of the space, and then tried to replicate what the type of error would be. So looking at different VRs, tracking errors and trying to replicate them, basically. And the idea of trying to replicate them as opposed to just generating them was that you would have the ground truth version and the lower quality version. So again, I don't know if you can hear these. It's very low. Yeah, but anyway, so there's an example there of the air and the clean motion. So there was lots of other tests that we did in that experiment, but for here, we looked at personality again. And again, the personality was changed or shifted because of the tracking errors. Again, openness and extroversion were the ones that were affected the most. Okay, so there are the only two studies, I guess, that we've looked at, and I'm sure there are others have looked at tracking errors and the effect on perception. The one last thing I want to look at is how many markers is enough. I think this is kind of related as well. And again, there's lots of researchers have looked at this over the years, looking at marker reduction. So like capturing lots and lots of motion, doing things like PCA or optimization to try to lower the number of markers that you need to represent emotion. Yeah, and I guess from Johansson's experiments, you could imagine that like a low number of motion. So I guess what do I mean by how many markers is enough? So there's on one hand, it's, you know, how many markers are going to identify you as, you know, all these rich properties. But then I guess it's also important to drive your character well. So again, it depends on the rate that you're using and all that kind of stuff. So we've looked at this in two different ways. This is back with Ludovic Hoyet in 2015, where we took a perceptual approach, unsurprisingly, to the idea of marker reduction. So we captured a high resolution of markers, and then we ran perceptual experiments to determine if we reduce the markers and use IK instead of the full FK, full kinematics, you know, at what point would people perceive? We had talking animations as well, or we had the full, and we tried all these different reductions. So yeah, that was an experiment. Do I have the results? So again, yeah, we used the perceptual approach, and we found the kind of optimal number of markers that needed. Again, of course, it was motion specific for the fingers because they're so complex. But like in certain circumstances, the static pose was enough. Especially for gesture, we found that like 4 finger and 2 thumb markers was enough. So that was the approach we used there. And in a more recent study with Edward Zell, we looked at facial landmark layouts for performance capture. So we took a slightly different approach to the general approach. So again, the number of landmarks on a face is usually what's used to track a face and to replicate it, usually in a blend shape model. So our idea, this was a Eurographics paper this year, our idea was to go backwards and start with the blend shape model and work out how many points were needed to drive that blend shape model. So we did an optimization approach where we placed markers where there was relatively high displacement. We wanted one good marker guaranteed for every blend shape. We then did a combinatorial problem we solved using linear integer programming. And we had a number of terms in the optimization. One of them included visibility. Sorry, these are all moving very fast. One of them included visibility to ensure that the landmarks could easily be tracked. And we came up with a new landmark layout. Again, this has to be computed whatever blend shape model you're using. Sorry, that keeps flicking. Whatever model you're using, but generally we tested it against other landmark methods and showed that a lower number of markers can be appropriate depending on the blend shape model that you're using. You know, there's data reduction that can be done there. Sorry. Okay, so I'm getting the 5 minutes. Oh, that was a 15-minute. Was it?
Yeah.
Okay.
10 minutes.
Oh, okay, great. Oh yeah, we've got a time. Yeah, so just summarizing all that, I guess. again, coming back to the point about motion and the fact that it dominates appearance, it is an interesting one. We've not found any really effective appearance much. We really feel that the motion dominates, but there is a phenomenon in VR, an illusion called the Proteus effect, which was kind of coined by Yi and Valenson, where the properties of your avatar are taken on by the user. So that's something that might actually be kind of different in VR. So they did experiments where they had things like taller avatars, and the virtual human, the person driving the avatar felt more confident when they were embodied in a taller avatar or more attractive avatar. So there's kind of effects like that we're not really considering in our experiments. You know, this idea that actually you may behave differently if you're embodied in a cat or something in VR. So then the tracking quality is something that we definitely found is important. So, you know, if you have low quality tracking, you know, it might look fine and it might look nice and everything, but actually it might be portraying the person behind the avatar in a way that you don't want them to be perceived. Or, you know, if you're a very extroverted person and all of a sudden you're not being treated in that way in conversations in VR, it could be because you've got poor tracking quality. So I think it's something that needs to be looked at a bit more. How much data is too much data or not enough data? That's another question. I suppose that on the one side you've got the richness of data in a small number of points, but then obviously you have to drive an avatar, so to make it realistic. So that's another question that I guess everybody, you know, we're all going to be looking at. So open questions then that I hope people might take on or start looking at. I guess there is this idea about like what other information can be extracted from motion. And I suppose how will that motion data be used in the metaverse is an open question. Is there potential for that information to be collected and stored about people? How will people represent themselves? We're running some studies at the moment to see what type of representations people create for themselves, and how to reduce motion capture data. Okay, so they're kind of the open questions. I'm very happy to take any questions after. There's also a number of resources if you're kind of interested. So I'm just kind of flying through a bunch of studies here, but we have a SIGGRAPH course with Edward Zell and Katrin Schiebrick in 2009, which all the notes are online about perception of virtual characters. We also had a course at SIGGRAPH this year on state-of-the-art in telepresence. So there's a lot, I have a whole section there on perception of characters for telepresence. And there's I have a chapter in this handbook on socially interactive agents as well, which kind of outlines the effect of appearance on perception of virtual characters. So if you want to know a bit more, I guess that maybe take a look at those, or I'm happy to answer any questions now as well.
All right.
Thanks.
Thank you very much. Any questions? No. Yeah.
Yep.
So thanks for the great talk. Really having fun with the social arts. I think there have been studies that have shown, at least with photos, that there is some perception of things like trustworthiness based on age, gender, ethnicity, and stuff. So I'd be curious to get your gut feeling about that. Like, do you think that it's just that motion is so much stronger signal than these biases, or maybe there's something about virtual characters which like disarms people and makes them forget they have these biases compared to just photographs? Or what's your sort of gut feeling about that?
Yeah, I mean, the studies that we did on the facial features and the traits, they were definitely coming through in virtual characters. So I wouldn't say it's a bias, you know, that virtual characters just they're not human enough or something. I would say that's definitely the case. But yeah, I think it's probably, like a lot of our studies as well, we used high quality motion capture data, and that just seemed to overwrite the other aspects. Now, as well, in some of our studies, we had actors portraying things, so they're kind of more exaggerated maybe than a real, you know, a human. Like some of our later studies, we have more natural conversational stuff, but yeah, I'm really interested to try that, where we look at particular facial features that are supposed to display, say, trustworthiness, and then whatever motion features that aren't, put them together and see what happens, you know. But we did an experiment like that with my student Ulva, where we looked at virtual characters that were supposed to be dominant, but actually we had no motion in those ones. And we found that the dominant character, it was a moral dilemma experiment where you had to kind of pull a trigger to, like, you know, one of those bridge where you've got a cart coming towards,
trolley.
The trolley experiment, yeah, exactly. So we did that kind of moral dilemma experiment, and the more dominant looking virtual characters did force people to make the more, you know, the more, I suppose, meme choices. So, but again, they weren't motion captured. So yeah, I don't know. I think it's an interesting experiment to try, and hopefully some people might be encouraged to do that. Yeah, and myself. Thanks.
Yeah, there's a question over there.
Well, I'm happy to. Yes, okay, thank you. That's a very fascinating talk. We really appreciate it. I'm curious about if you have any insights into building empathy through avatars, you know, being able to put yourself in someone else's shoes, so to speak, and what some of your work might help, you know, give insights into it with that.
Yeah, I mean, that's an area I guess Mel Slater's lab is working on quite a bit. So they've looked at like bias, racial bias, for example, and very, very powerful to put yourself in the body of somebody else, and massive effects even afterwards. You know, so it really, you know, they've done some work as well on domestic abuse, and they've found really positive effects of getting that empathy from that experience. So yeah, definitely. I think empathy is an interesting one. We're looking at empathy at the moment with respect to realism as well. So if the more realistic the character, does it evoke more empathy? So far we found that it does. Again, it doesn't seem to make a difference, the character representation. It's again the story and the personality seems to be the thing that's evoking the empathy. I mean, I feel like that if the character is more realistic, surely you're gonna. But again, I guess it speaks to the fact that we still don't really know how our brain is really perceiving these virtual characters. Are they, you know, some kind of a cartoony thing, or are they being represented as real interactions? I guess that's something that needs to be figured out as well.
Yeah, it's interesting. It may depend on the kind of thing. Like if someone may have a physical disability of some type, then I would expect motion cues to be very, very important for that.
Yeah.
But then for racial kinds of things, maybe skin color is enough. So it's a purely visual thing for us. All those are probably motion things as well. That who knows.
Yeah, that's true. And the combination of the two. And I mean, I think, you know, like I'm presenting kind of the results where motion was very strong, but we did find some other experiments, you know, not with motion, but looking at other things where it was very complex, the interaction between the motion and the appearance. And it not always going in the direction you expect either, you know. So I think there's lots of, and this, I think that's one of the issues as well, and that's one of the struggles I've felt over the years with these experiments is virtual characters have so many parameters that you can change. You know, you can change skin color, the hair color, the realism, the lighting. You know, we ran a bunch of experiments where we just changed the brightness of the light on the virtual character and found effects like emotions were perceived more intensely, or the character was much more appealing if the light was brighter. So yeah, there's unfortunately in some ways too many factors almost. So it's trying to narrow those down and find out what's really having an effect.
So given the perfect tracking, you would be sharing a lot of do you think it's also some kind of privacy controls or decide what you want to share?
Yeah, I think so. Yeah, there's going to have to be something like that, I guess. Yeah, to know, first of all, is your tracking motion being stored somewhere? I think that's important. Yeah, definitely. I definitely believe that's going to be important.
What kind of technology would
Oh, to try to hide, yeah. I mean, I suppose there's a kind of parallels with deep fakes as well, right? Because you're like driving a photorealistic character, video with a different person's motion. So it's kind of, yeah, there's similar kind of perceptual effects going on there. And there are similar questions there, I guess, about, how do you authenticate who the person really is? Or, I mean, sometimes it might be useful to hide some of these personality traits of that. So, but again, like machine learning, if it's being used a lot for the motion, it's again another kind of question mark as to what's that going to do to the perception of you and how you're represented. But yeah, I don't know how to police that. Yeah, someone will come up with a good solution, I hope.
Thanks. Really appreciate the talk. So I have two quick questions. We have a big comment here. So that was the exploration.
Yeah.
So a quick comment there. So saying that if you were to do it again today,
Yeah.
you would want to.
Yeah.
So my first question is, people seem to be really different.
Yes.
Yeah. So I wonder, what do you think? Do you think motion is sufficiently discriminated to draw parallel to the
Yeah, I guess that's why studies it's important to include more diversity in these kind of studies, because definitely back in the 70s and that, when the studies we were advocating, it was just male or female. I mean, our experiment used a scale from male to female, so there was a possibility to place the scale wherever we wanted. But yeah, I guess I think motion carries all that information. Yeah, I don't know. I don't know for sure, but my gut instinct would be that yeah, it is.
That's great. I mean, that was my next question is longer, I think. Okay. So
Yeah.
motion is a highlight.
Yeah.
Right now, gender is a one dimension. So do you think that it's possible to discover definition of gender?
Oh.
I mean, in nature, there are creatures whose genders are actually
Yeah, well, I guess, yeah. Yeah, I guess so. But I guess, again, if you want to try to identify those, different factors, you need, again, data sets and labeling and, so I don't know, you get down to the question of how, having to know yourself, you know what I mean? But yeah, I don't know. I mean, any of the studies we've done, there's been a quite, yeah, it's quite clear definition of male, female from the motion that we've taken. But again, yeah, it was a small data set, and I think it would be very interesting to look at wider sets. Yeah, but I don't have any answers on that one yet.
Thanks. Super interesting talk. You gave me a lot to think about, and one of the things I found really interesting, the results that you presented, is on the identification of representatives, like identifying the friend from the motion, and it of course depends on the type of motion. But do you know at what scale that becomes possible? Like, a dozen individuals to identify each one. At what point does it become challenging to identify individuals?
Yeah, I mean, those experiments that were done in the 70s on investigators, that it was probably from a pool of about 20 people, and you were identifying, but we've done experiments on this in the context of crowd simulation as well. So like identifying cloned animations in a crowd. So people were definitely less good. They weren't as good at identifying when motion was replicated in a crowd, than they were when appearance was replicated, for example. So you could get away with 3 animations, let's say, as long as they were synchronized all together. The crowd looked quite homogeneous in terms of the way they moved. But I guess that's more for like making a crowd look homogeneous, as opposed to, would you be able to tell your friend from 100 other people? I don't know. Yeah, I don't know.
I also have a follow-up question, and it relates to want ourselves perceived. You know, one of the actions of participating in the environment and parents, bodies sort of like any creature or any individual we want. So now it seems that like motion is part of that. So we have sliders to change the visual appearance of the characters and avatars, but do you think the future is going to see sliders and mechanisms for mapping to different motions or transforming emotions?
Oh, definitely, yeah, I think so. I think so for sure. I mean, there's a paper yesterday looking at gesture, style, and things like that. So, you know, yeah, you can, if you could just use a slider, you have to change, make yourself more extroverted or charismatic or something, you know. I think that's definitely possible, going to be possible, yeah. But yeah, motion, synthesizing motion, I guess, is, at the moment anyway, is a bit trickier than maybe synthesizing visual. Yeah, yeah, yeah. So I think it would be possible.
One more question at the back.
Thank you. I have a question. Great talk. I have a question that's similar to the last one. I'm wondering if there's the more find out like it's freedom to choose a new avatar. You also mentioned that some people sort of get affected. You might come across as like all avatar.
Yeah.
Are there any studies on the underlying populations of people when they create their avatars? Do they want to come across as they, you know, believe themselves to be in the real world, or are they trying to enhance their personalities, or maybe, you know, mitigate the shortcomings, or
yeah, there are definitely others studying this, but we ran a study just recently where it was a class of students that were going to be meeting each other in VR, and before the task they had to do a group experiment. We got them to create their own avatar in all space VR, so their choices, they could create quite wacky looking characters if they wanted. And we then got them to do a questionnaire, because we love questionnaires, and we asked them about, you know, were they, you know, what was the personality of the avatar that they selected, what was their own personality, and were they generating an avatar that was an idealized version or a fantasy version of themselves. So I don't know if it was because it was a class task, you know, they knew that they were going to be interacting with their classmates, and it's a kind of a more formal environment, but majority were creating characters that were this, you know, to represent who they looked like themselves. You know, there was a small percentage that went for more idealized versions of themselves, but majority went for themselves. And actually we went further, and we first of all, we looked at other people's perception of the avatar that was created, and we found that there was correlate, you know, that they were being perceived as the personality of the person. So they had created something that did represent their personality well. Does that make sense? I don't know. Yeah. But yeah, so I think, but I guess that was again a group scenario in a classroom setting. But I guess if you're going to, you know, be going to a virtual concert or something like that, you know, chances are you probably want to make yourself have crazy hair and stuff, you know, I don't know. Yeah, I know, like, I know myself, like the first thing I always do when I go into a creator is like try to make one that looks like myself. Or I know I had to give a talk in a Laval virtual conference during the pandemic, and the night before I was like getting my avatar to be dressed like kind of in a smart suit or something. So I think you kind of, yeah, try to represent yourself in the situation that you're going to be in, I guess. Yeah.
Any more questions? Great. If there's no more questions, shall we thank our speaker one more time? Thank you. All right, just before we move on, let me introduce a little bit on what happened next. So we will have a social event right after lunch, or maybe around in the middle of the lunch. I'll tell you more. So first thing, make sure you wear your name badge. I actually forgot today. Sorry, I'll find my out. And such that people know that, especially during the tour, they know you are one of us. And second, well, we book some buses, we book some coaches. The first one will arrive. We actually booked 2 of them. The first one will arrive around 1:45. And we'll take a coach and then we'll go to somewhere close by, and there'll still be around 5-6 minutes of walking to the site because the bus cannot go into the city center. You know, this is a very old city, the bridge will break. So seriously, so we still need to walk a bit. And yeah, I think that's what you need to expect. Now, if you do join the tour, it means that your lunch will be quite short. So I'll leave it up to you if you wish to join the tour or if you wish to have more time for lunch and chat with more people. So it's totally optional and up to you. All right. Now, I also need to say that logistically speaking, this is probably the most complicated things in the whole conference. And we put a lot of efforts to make sure everything should be okay. We just can't be certain until things happen. So if there's anything not going exactly according to plan, please bear with us. I'll thank you in advance. Thank you very much. Lunch should be out.